I'll now briefly talk about the rest of the slides in this set. Again, we will have gone through this in the synchronous section, so I'm not going to go through it in detail. We start out by introducing the relationship between ideal gases and the temperature scale. Then we talk more about the triple point of water. I introduce the ideal gas law. I introduce the equations of state, and I also include some other equations that students might have seen in their university physics class. They'll be discussed in detail later in the class. I then talk about the idea of pressure in an ideal gas. I'm not going to go through this in any detail in words because everything you need to know is actually on the slides. So basically that shows us how to calculate the pressure on the gas based on the velocity of the molecules in the gas. And one thing in particular, we'll use RMS velocities frequently, and this is the definition of what the RMS velocity is. Then this is just a further discussion of equilibrium. Here's a definition of equilibrium states. At this point, I introduce the idea of a homogeneous fluid. And then I introduce the Zeroth law of thermodynamics. It's the Zeroth law because it was thought of long after the first and second laws. R.H. Fowler was actually Paul Dirac's PhD supervisor, so this was something that came along in the 20th century rather than the 19th, like the other laws of thermodynamics. The Zeroth law allows us to develop thermometry. And here we introduce heat and work. And finally, the last few slides are about the concept of mean free path, which I introduce at this point mainly because we're going to contrast it with some other quantities later in the course. So this is the final expression for mean free path, and it's basically the distance you can expect a molecule to travel before it collides with another molecule. So we'll end the introductory material at this point. As I have said, this is material that you may or may not have seen before. We'll be using it. It's here mainly so that if you have seen it before, you can go look in your earlier class notes. Everything that we need to use in detail in the class will be introduced again, but this is just an overview of what you might have seen in your past classes, either in University Physics 1, 2, or 3. But for some of you, it may have been your high school chemistry class or your high school physics class since you saw some of these concepts. So with that, we'll end this particular video.